Uh, Hello, everyone. We are Ernesto, Eric, and Ben. We're from Professor Bergman's 110 Manufacturing Processes class, and today we'll be discussing our GD&T tolerancing scenario for a mechanical keyboard switch casing. So our product for this tolerancing scenario is a MX mechanical keyboard switch, and on the right, you will see our CAD model of the part. And on the right, you will see the physical parts we referenced. So here, this is an exploded view of our part. And for our tolerancing scenario, we will only be focusing on the top and bottom housing mates. So here are the two mating parts. On the underside of the top housing, there are 4 prongs that are a snap fit into slots in the bottom housing directed by the arrows. And here are our considerations for a functional assembly. So we have the form where some of the faces of the latches must be parallel or perpendicular to another in order for the latch to work correctly. We have the size where there must be a specific latch surface area size that must be controlled for the latches to work as intended.
We've then got orientation. The latches must be pointing inwards, and the notches that the latches fit onto must be pointing outwards. We've got location. The latches must be at the corners of the housing relative to the top plane. And finally, we've got profile. The latches must be approximately the shape as described in the following drawings. Note that the diagonals at the bottom of the latch allow for the top housing to slide onto the notches of the bottom housing, and the latches of a specific length as well to reach those notches. The next slide. According to the mechanical keyboard switch vendor, Lumakeebs, injection molding is the process used for manufacturing the housings of mechanical keyboard switches. Additionally, Axometry states that the injection molding process has a dimensional accuracy of plus minus 0.025 millimeters to plus or minus 0.1 millimeters. We couldn't find a specific dimensional accuracy that key switch manufacturers require, so we estimated that 0.05 of a millimeter tolerances would be sufficient. And here we see the GD&T drawing of the top shell of the Cherry MX switch. For the top housing, notice that parallelism was used relative to axial datums A and B to define the location of the latches. This ensures that there are 0 degrees of offset between the datum and the feature.
In this next drawing, we applied true position to define the location of the base on the latch on the bottom of the top housing relative to the axial datum C. True position locks rotation and distance of a feature relative to the datum. Here's the GD&T drawing for the bottom shell of the Cherry MX switch. Continuing with the bottom shell part of the drawing, we have another example of parallelism. We used it to indicate which of the 2 faces of the latches needed to be aligned for the correct mating with reference to planar datum A. Finally, we use perpendicularity to specify the area in which the latches interface are supposed to be perpendicular to the vertical face represented by planar datum B. Perpendicularity is a 90-degree offset between 2 planes or axes. That concludes our presentation. Thank you for watching.